Okay, I'm going to talk you through two examples of quadratic inequalities. So the first one we've got is x squared plus 4x take away 5 is less than 0. Okay, so first thing you should be able to notice is that we can factorize this expression. So we're going to get x plus 5 in brackets multiplied by x minus 1 is less than 0. Okay, so let's see exactly what this looks like on a graph. Okay, so here's my axes, here's y, here's x, okay, and the actual parabola goes to the graph like this, passing through x is 1 and x is minus 5. Okay, so what you need to be thinking now is at what points is my parabola less than 0? In other words, where is my parabola less or below the line y equals 0? Okay, so what you've got to imagine is that this is your parabola and this is the line y equals 0. Okay, so where is it below the line y equals 0? Well, that is here in this section where it drops below the x-axis, the line y equals 0. Okay, so the actual values we're looking for are here for x. Okay, so I can write my answer straight off as minus 5 is less than x is less than 1. Okay, so the points that I'm interested in are bounded between x is minus 5 and x is 1. Okay, so let's have a look at another example. In this case, what we've got is x squared minus 3x minus 4 is greater than or equal to 0. Now, this can also be factorized. Remember that you can also use the quadratic formula, that works as well, or completing the square and solving. But I've chosen two nice examples that both factorize. Okay, so I've put it into brackets, x minus 4, x plus 1. Let's have a look at what this looks like actually on our graph. Here are my axes again. Here's y, here's x. Okay, I know the graph is going to look something like this, going through minus 4 on the y-axis. On the x-axis it's passing through 4 and minus 1. That's given by the brackets. Okay, so this time around we're asking where is the parabola, okay, greater than or equal to 0, or greater than or equal to the line y equals 0. So y equals 0, that's the x-axis. Where is my parabola higher or above the line y equals 0? And that is here. Okay, it's over here and over here. That's where it is above the line y equals 0. So the actual values I'm interested in are here and here. Okay, these of course go on to infinity in both directions. Okay, so it's an infinite number of points. Now, because these are two distinctly different regions, okay, they don't overlap, I need to write two inequalities to define this area, okay, this region rather. So x is less than minus 1, and over here x is greater than 4. All these are greater than or equal signs actually. Okay, so x is less than or equal to minus 1, and x is greater than or equal to 4. We can't write it as one big inequality like we did for the previous example, for this one. Okay, we can't do this because it's not just one region, it's two distinct regions. Okay, so that is basically how we work with quadratic inequalities.